Okay, so our job for the first two problems is to figure out whether or not these problems are growth or decay and what the y-intercept is. So let me do the y-intercept first. Right now these problems are called exponential problems, and the reason why they're called exponential problems is because look at the exponent location. They're exponentials because the exponent now is a variable. That hasn't happened before. The exponent has always been a number, like a squared, a cubed, to the fourth power. Last unit, the exponent even started becoming a fraction, and when the exponent was a fraction, it turned into radicals, square roots, cube roots, fourth roots, etc. But now this unit, what makes this unit so tough is the exponent is now going to be the letter or the variable x. When you have an exponential problem, the y-intercept is going to be very straightforward. For the first problem, the y-intercept is the number that is by itself multiplying onto the part that has the exponent. So notice how the 2/3 has the exponent and the 3 has the exponent. Because those have the exponents, that makes the other number the y-intercept. So the y-intercept for problem number 1 is going to be x is 0, y is 3.1. Remember, function catalogs, y-intercept, x always has to be 0. And then the y-intercept for the second one is x is 0, y is the fraction 2/5, because y-intercepts x is always 0. So that's the y-intercept part. Now, what about whether or not it's growth or decay? Growth or decay comes from the two numbers that I circled in blue inside the exponent of x. So the exponent of x, what's inside of it is 2/3, and inside of it is 3. Now notice how this number is between 0 and 1. And notice how this number over here is bigger than 1, not between. It's bigger than 1. Because of that, if it's between 0 and 1, that makes this decay. Since this is bigger than 1, that makes this growth.